All right, ninth graders, we are looking at page 53, and we are going to put this all together, the stuff we've learned about residuals, and we are going to decide what is a residual plot, and we are going to give an example. So first, a residual is the vertical distance from the point and the line of best fit. We've got that defined there. So I want you to figure out what the approximate residual is of each of these points listed here. So the first point is 3, 7. So I'm going to find that in my graph. To the right, 3, up, 1, 2, 3, 4, 5, 6, 7. Now, do you see where that dot is compared to the line of best fit? That dot's above the line of best fit. So I know this is going to be a positive residual. So if I'm looking at that, that's at least one space and like maybe half a space as well. So I'm going to say that my residual is about 1.5. And notice that's a positive 1.5 because it was above the line of best fit. So let's try the next two. I want you to take your second to pause my screen, and I want you to find the approximate residual for number 2 and the approximate residual for number 3. Push pause, find those two. Okay, hopefully you paused and you were honest, and now we can talk about our residuals. So the approximate residual of 4, 2, I go to the right 4, up 2, and here's my dot. Now that dot is below the line of best fit, and it looks like it's actually only one space below. So to show that it's one space below, I would need to say -1 for my residual. Okay, what's the approximate residual of 9, 8? So to the right 9, up 1, you can't see that. 1, 2, 3, 4, 5, 6, 7, 8. That dot is on the line of best fit. So how many spaces away from the line of best fit can it be? Well, if it's on the line of best fit, it's 0 spaces away. I know that was a silly question, but we can have 0 residuals if it's on the line of best fit. So we can do a residual just by looking at the graph. On this example, we'll talk about how to do a residual using our actual minus our predicted amounts. So I'm going to go over this middle section because this is super important for answering some of the questions that we have. A residual plot is a graph that shows the residuals on the vertical axis and the independent variable on the horizontal axis. So the first thing I want you to remember is what a strong linear fit means. So a strong linear fit, the distribution of residuals around the x-axis, it is going to be random and really tight in there on that x-axis. So you can see the dots are above and below, that's the random part, and then they're close together. They are very close to that predicted amount, which means that you're not too far above predicted, you're not too far below. Your predictions are really great. That means it's a really good line of best fit. That would also be like a really great correlation coefficient, I'm sure, because it's going to be very pushed together, all that data. Now, a weak linear fit still has the words linear in there, which means that they are going to be random, but the weakness means that they are going to be loosely distributed above and below. So you can see here, you've got some data above, some data below, and it's spread out. It would have a lower correlation coefficient. Your data is going to be more spread out on the graph, but it is going to be trending well with the line of best fit, just not as good as a strong linear fit. Non-linear fit would mean that the distribution of the residuals is not random. If it's not random, then you are going to see a pattern like this one where it's above, below, and then above again. Or it could go above, below, above, or it could just be like a straight line being off. Any of those things would be a non-linear fit. Let's go to our example now. The line of best fit for the scatter plot is below. So I gave you the equation, y, I'm not sure why the y has a really fun party hat, but I like it. Y equals 0.74x plus 1.4. And you've got all these data points. So we are going to look at the graph, and we are going to figure out what these actual values are, and we're going to figure out what the predicted values are. So the actual would come from the graph up here. So for example, if my x value is 1, I go to the right 1, and the dot is actually up 2 spaces. Then I go to the right 2, and it is actually up 3 spaces. Then I go to the right 3, and if you notice for 3, there are 2 different dots that are 3 spaces to the right. Notice we have 2 different 3s in our table. So I've got up 2 spaces for one of them, and the other one is 1, 2, 3, 4, 5 spaces. Okay, so here are our actuals. Yes, you can fill in the rest of your table, so I want you to push pause, look at that graph, and find your other actuals. Please don't just wait for me to fill them all in. I want you to actually try this because this is really great practice when you can get immediate feedback. I know sometimes you get annoyed on your quizzes because you don't know why you did something wrong. Well, now's the time to try something and figure out why you did it wrong. So pause your screen and fill in the rest of those actuals. Okay, so you should have gotten these for your actual amounts. And now let's look at our predicted. So our predicted, we're using this equation and we are using our input of X. So I know that my first one will be 0.74. I typed in 0.074, let me fix that. 0.74 times my first X value, which is 1. Plus 1.4. So my first predicted amount is 2.14. Okay, for my second predicted amount, I'm going to do 0.74 times 2 plus 1.4. And I get 2.88. Then I have 0.74 times 3 plus 1.4. And I get 3.62. Now I had another 3 for the next input, so I can use 3.62 again. All right, pause your screen. I want you to fill in the rest of these predicted amounts and check to see if you did them correctly. Okay, so we've got all of our predicteds on there. You can pause your screen and look at how, if yours are the same as mine or if yours are different, then that's great. You can fill yours in properly. So now we want to find the residual. Now remember, to find this, we talked about this in our last page of notes. We said that you have to do the actual amount minus the predicted amount. So I've got my actual here. I'm going to subtract my predicted amount, and that will equal my residual. So if I do 2 minus 2.14, I get a residual of negative 0.14. Okay, then if I do my actual minus my predicted, I'm doing 3 minus 2.88, and I get 0.12, and that's a positive 0.12. And I'll put a 0 there because I feel like sometimes people get confused when I don't. Okay, then I'm doing 2 minus 3.62, and I get negative 1.62. Okay, so for all of these, you are doing the actual minus the predicted, and you are going to get your residual amount. I want you to finish calculating these on your calculator. Please don't do these in your head because some of them are some pretty fancy subtraction with decimals. So push pause, fill this in, and then we'll check our answers in a moment. All right. Now that we have our residuals, we are going to make our residual plot. So if you remember, a residual plot, we have our inputs along the x-axis, and then we plot our residuals above and below that. So our first coordinate would be to the right 1, down 0.14. So this is just barely below. The next one is to the right 2 and up 0.12. Then we have to the right 3, down 1.62, so a little past 1.6. To the right 3, up 1.38. So that one's above. We see we got above and below there. And I'm plotting these from up above. So I've got my x value is 4 to the right, down 0.36. Then I have 5 to the right, up 0.9, almost to 1. 6 to the right, down 0.84. Then also 6 to the right, up 1.16. 7 to the right, up 0.42. 8 to the right, down 1.32. 8 to the right, up 0.68. And 9 to the right, down 0.06. That is a beautiful looking residual plot, if I do say so of myself. So let's categorize it. Would you call it a strong linear fit? Would you call it a weak linear fit? Or would you call it a nonlinear fit? And I want you to decide why. You're gonna write it right here. And I want you to explain why you chose that. Why did you choose a strong linear fit? Why did you choose a weak linear fit? Or why did you choose a nonlinear fit? And I want you to answer that for today's question. So what sort of fit was on our residual plot? And why did you choose that sort of fit? What did it have as its characteristics that made it that way? Okay, answer that, and then you can move on.